Addition and subtraction of radicals is very much like, I'm going to compare it to combining like terms when we're doing polynomials, okay? So if you remember when we combine like terms, if you have a 2x and a 4x, and you want to combine them with a plus sign, you can do that, and what do you get?
6x.
So what we're doing, 6x. So what we're doing is we are adding the coefficients, and we are keeping the term the same. It's just like saying if I have 3 apples and I want to add 7 apples, then what do I have?
You have
10.
I have 10 apples. Do they become square apples?
No.
No, they're still apples, right? Yeah. Just like when we combine like terms, 2x plus 4x does not become 6x squared. It's just 6x. We're counting how many x's we have. So this is going to be a very similar concept. We are going to have something like 3 times the square root of 2 plus 3 times the square root of 2. Okay? So we would say, how many square root of 2 do I have? How many of this value do I have?
6.
Yeah, I have 6 square root of 2. There's 3 here. That's 3 times the square root of 2, which is like having the square root of 2 3 times, and I'm adding them together. Plus 3 more gives me 6 square root of 2. See how it's very similar?
Yeah.
Okay. That being said, if I have, why do I keep writing 3's? 4x squared plus 5x, what do we get?
We get
4x squared plus 5x.
Exactly. You cannot combine those because they're not the same type of term. 4x squared plus 5x. The same thing is going to go for radicals. If I have 2 square root of 2 plus 6 square root of 4, I cannot combine these because what's under the radical is different. It's different types of terms. You could use that language. It's not really 100% correct, but it makes sense to us because of the way that we learn to combine like terms, right? Now, can I simplify either one of these?
Yes.
What can I simplify?
You can take the 4
Mm-hmm.
and you can make that a 2 and then do 6 times 2.
Now, that did not affect the 2 square root of 2. It only affected the 6 square root of 4, which becomes 12. I still cannot combine these, okay? This is the type of situation in our polynomial lessons where we would have had like 5x plus 10, an x term plus a constant. Can't combine them.
So 2x squared plus
2x squared plus 12 is the simplified version of this, becomes that, okay? You cannot combine them. If I have that's a 5 square root of x minus 9 square root of x, what do you think I'd have?
Negative
4 square root of x.
Negative 4 square root of x.
Miss Kenny, what was the 5x plus 10 part of?
That was just another example.
Oh, okay.
I was just comparing this to polynomial
Okay.
terms, or variable terms, I should say. You're right, I should. All right. Let me do another example here. If I have the square root of 27 minus the square root of 12.
Find the square root.
It'd just be the square root of 27 minus the square root. Yeah, it'd just be the square root of 27 minus the square root of 12.
No, whatever the square root of.
You couldn't you just take the square roots like 2,
Oh.
2 and 3, and then
9.
Okay.
the 2 to put
Yeah,
outside.
I can simplify each one. So this one would become 9 and 3, like you said. And then what would this one become?
3 and 4.
No, it'd be 2 on the
Six and
outside
three.
and
Why
3
two?
on.
Right, but let's not skip
Or
the
six
step in
and
between.
Okay.
Okay, so then that simplifies to,
3 to the square root of 3 minus 2 to the square root of 3. And then you can put those together.
yes, because now the radicals are the same. The radical portion of each term is the same. So now I can combine them using subtraction in this
And
case.
then you
Wouldn't
can
it just be
do
the
1.
square root of 3?
square
It would
root
just
of
be 1 square root of 3. Just like with variables, you don't need the 1. So it's
three.
just
Square root of 3.
square root of 3. Because 1 times the square root of 3 is square root of 3. So you don't need that. So that would be your answer. It is a good answer. He's talking so low. He wants me to sound like I'm crazy. Like, he whispers things and then waits to see if I hear it or not.
It's a good answer.
It's Cameron, by the way, for you guys watching the video.
We don't know. Or maybe
Well, I want the public to know, you know.
Yeah, public.
the public.
Cameron's the troublemaker.
Oh, 8th grade park
All right.
5 search for green eyes. Search for dirty blonde
Actually,
hair.
5.
Search for.
Yeah, you do.
Yes, you do.
Guys, don't make me ring my bell in the video.
Okay, well, there.
Damn, guys.
Be quiet, guys.
Who wants to try this one?
No, never mind.
I would like to try it.
Lexi, come on up.
Okay, like here.
Yes. Right here. I'm going to get you set up.
I don't have
Okay.
the best handwriting.
That's okay.
Okay, so you take it. Okay, so
Listen.
Oh, gosh.
first thing you do is you take it and
Shh, guys.
equals. So the square roots of 45 are 5 and 9.
Put the perfect square first.
9, 5, then plus the square roots of 80 would be 8 and 10.
Does that help us, though? Is either one a perfect square?
Oh, no,
What would help us here, guys? What's the
4
biggest
and
perfect
2.
square? 4 and
Oh, wait,
20?
wait, wait,
Two.
no.
no, I mean 4 and 2.
Wait,
Oh,
it's
you want
80 divided by
perfect
5.
square? Oh,
What's
that's
80 divided by 5?
4 and 2.
4 and
18.
20.
4 and 2 and 10 would
16.
16. Okay.
Okay.
16 and 5.
Oh, okay.
Oh.
So,
No, you were on the right track. You said what's 80 divided by 5? That's because you know you need the radicals to match if you're going to be able to add them together. So that was a perfect way to start.
and then, so pretty much you're not gonna have anything in the square root ones, right?
So
No, you will.
equals.
See?
Well, then because you have 5 squared. Oh, wait.
No,
wait,
you don't combine them. That's the idea. You don't combine the radical part. You just combine the coefficients. Perfect.
Okay.
Nice job.
It's my thing.
Okay. Let me show you one more type, and then I will let someone else try one. Okay. So, let me find one here. Let's do one with a whole bunch of variables in it. That'll be fun. Sorry if I'm making you sick with the moving of the video.
I like variables.
Yeah, we like variables. All right, square root of x squared y plus 4x squared y plus 9y minus
Okay, that's it.
y cubed.
Wait, oh, screwed.
What, was that not what you wanted? You said you like variables.
I
Yeah.
got it.
Let's do it.
Cameron's
All right, so we want to simplify each radical. And our goal here is to have what's left under the radical be the same for each grouping or each term so that we can combine them all together, right?
So can't we just get one and then the others are?
Sometimes they don't all combine. It's really important that you just simplify them all to the best of your ability.
3.
Okay. So first one right here. What do we do?
X, Y.
I can take the x out
And then square root of y.
because that would separate into the square root of x squared and the square root of y. So
X and Y.
2x,
2x,
and then square
And
root of
then
y.
2
2x, and
x.
Square root of y.
And then
Y.
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 Okay.
Plus 3
Plus
square root of
3
y.
Square root of Y.
And then
And then y,
Y is
squared
square root of
y.
Yeah.
What?
No,
Wait, is it y or y
to the
squared?
square root of y.
Yeah.
Right, because it's y squared under the radical. When we take it out, it's just y.
Okay, so they'll have y.
Okay, now they all have the same radical. That's good. Right?
Yay.
Wow.
So we need to start combining the factor before the radical. We have an x and a 2x.
3x.
Okay, 3x.
3
So 3x and then
Plus. No.
Plus minus y.
Minus
minus y
y
plus 3.
plus
plus
3.
3.
Okay,
Square
So-
root of Y.
to the square root of times the square root of y.
Yes.
Now, this looks like only the 3 is being multiplied by the y.
It does.
Parentheses would work. Okay, that's one way to put it. Yep. Actually, that's how they have it in the book.
Cool.
Cool.
Yep.
Okay.
Another way that we could have gotten here was to combine just the like terms. So 3x was the only thing that could be combined, right? Like that. And then we have the plus 3 and the minus y. And then to actually factor out the GCF, which is the square root of y. Do you see that?
Yeah, I like the first idea
The
better.
square root of y is the GCF, which we could take out.
Oh, I see what you did. Oh.
Yep. And then commutative and associative properties, these and these are exactly the same. So that's the same answer, just two different ways to go about it. But I will say in this case with radicals, generally the radical part comes after the non-radical factor. So this is what you're going to see more often than this. Okay?
Cool.
Make sense?
Isn't it?
It does.
All right.
make sense.
And then let me show you, hold on, I want to show you a rational radical, I guess it's called. Rational radical. You could, that does sound like a song.
Radical.
All right, let's see. 2/3.
Oh no. we're gonna
Minus.
surprise
Take your
my
meds,
friend.
Eli.
Are you whining? Stop whining.
And then Eli.
We don't whine in algebra honors.
No, you
I'm
don't.
saying.
There's no whining in algebra
Take
honors.
your meds?
Okay. How do I simplify these?
What?
Oh, okay.
Common denominator, yeah.
We did.
Times 2 to the
Times
3 times 2 to the 2 times 2 over 2.
I can tell by the
Would you
voice.
rationalize the?
Okay. Well,
Where-
you're both on the right track, okay? We do need common denominators if we're going to combine them. Right now, what we have is the square root of 3 and the square root of 6. How do we get them the same? What do we need to do?
Multiply times the square root of 6 on that side and then square root of 3. So rationalize the denominator.
That would make them both 18. Can we use something smaller?
Yes.
What's the
six.
GCF of 3? And we can use 6. So how do I get the square root of 3 to turn into the square root of 6?
Times the square root of 2.
Times, yeah, it's not just 2.
Square root of 2.
The square root of 2, because if you just multiplied by 2, the 2 would be on the outside of the radical.
Square root of 3.
No.
So we would need to multiply by the square root of 2 over the square root of 2 on this side.
And then you get 4 over 6.
Square root of 4
and then,
over the square root of 6.
wait,
Minus.
okay, so we could just put
Minus
2.
Oh, God.
We can. So now we can combine these, right?
So trace over 6.
Well, no.
makes-
Shh. We can't combine them. We need to simplify them first. We have 2. Let me move this up.
Wait, we're just back to
It would be.
2 square root is over the square root of
2 over
6.
6 minus
Minus
1
1
over
the
6.
square root.
Square root of 6.
Oh, the square root of 6.
hmm
Oh.
Now they have common denominators, so how do we subtract these?
You would just do it.
You
would-
one
it would
over the
be-
square root of 6.
it would be
then
1
you
over
have
the
to
square root
square
of 6.
Okay. So then we have 1 over the square root of 6, which is looks pretty simplified, but what do we
And then we need
You
6.
have to rationalize it.
Then we need
rationalize the denominator? So how do we rationalize the denominator?
So 6 over 6.
No.
Square root of 6
Square
over
root of
6.
6.
Square root of 6 over the square root of 6,
Right.
And then
Okay. which equals
that equal 1 over.
No.
That equals-
1 square root of 6
Square
over
root of
6.
over 6.
Do I need to write the 1?
No, square root of 6
No.
over
Square
6.
Square root of 6
over 6.
over
Which
6,
equals the answer.
which equals the answer.
Why does that have to know
It's called rationalizing the denominator. You cannot leave any radicals in your denominator. Were you here that day?
She was here yesterday.
Okay. I don't know if we talked about that yesterday. Did we,
Oh, no,
Lindsay?
she was taking a test.
Yeah. Eli, stop talking, please. Okay. Lindsay, do you remember rationalizing? Yeah, it was. Okay. So that was just because we have to always rationalize the denominator. Okay, Carson wants to try one.
I do.
Well, why does he get to try one?
Because he asked
I
first.
just answered
It's a little-
You guys are
Okay,
really
guys,
whiny
everybody,
today.
audience,
I
this is Carson Marsh.
pencils.
Wait for it.
6'3".
I don't think we need his profile.
Dirty blonde hair.
Listen,
You can't
Alex, you're going to creep us out. That's enough.
For real. Okay,
Husband
so
and
Please
daughter.
take
better than this.
Yes.
Okay.
Well, no, you better use this.
Okay, better use
He
this
is one for fun.
Okay, our problem,
Harvard or something.
shh, guys, do we want to see another variables problem or do we want to see another radical
You know,
rationals?
The hardest problem. Give him like a
No.
collegiate.
Answer my question. Do we want another variables? Okay. 16x minus 16,
20th.
Wait, is
and
that
that's all
in a-
under a radical,
I can't even see.
plus, and this is all going to be under a radical too, 25x cubed minus,
Oh, cube. So.
mhm,
So